about the product-product relationship or relationship between two outputs. A product-product relationship, it deals with the resource allocation among the competitive enterprise. जो अगर दो प्रोडक्ट्स हमें प्रोड्यूस करें या दो अलग एंटरप्राइज है तो उसमें हम रिसोर्स एलोकेशन कैसे करते हैं, ये क्वेश्चन यहाँ पे डील होता है. The goal of product-product relationship is profit maximization. Now, under this relationship, inputs are kept constant while output are varied. In factor-factor relationship, we have seen that their output is kept constant and input are varied, but in product-product, input are kept constant and output is varied. This relationship guides the producer in deciding what to produce. Now, this relationship is explained by the principle of product substitution and law of equimarginal returns. Based on these two principles, we explain the product-product relationship. Now, this relationship is concerned with determination of optimum combination of the products or enterprise. In this case, the choice indicators are substitution ratio and price ratio. And algebraically, we can express this relationship as Y1, that is, first product is function of second product, third product, and so on. So for simplicity, we will just consider only two enterprise. Y1 is function of Y2. Let us see first production possibility curve. The basic concepts in product-product relationship. First is the production possibility curve. Now, production possibility curve or PPC, it is a convenient device for depositing two production functions on single graph. दो production function एक single graph में represent करने के लिए हम production possibility curve use करते हैं. Now, this curve represents all possible combination of two products that can be produced with the given amount of input. हमारे पास input level दिया गया है, तो उस input use करके हमें combination of two products produce करना है. So the PPC curve, that is production possibility curve, it represents the all possible combination of two products, product A and product B, that can be produced using the given level of inputs. Now, this curve is also known as opportunity curve because it represents the production possibilities or opportunities available with the limited resources. जो भी हमारे पास resources है, उसे हम कैसे इस्तेमाल कर सके, कौन से opportunities है, तो इसलिए उसे opportunity curve कहते हैं. It is also called as iso resource curve or iso factor curve. Iso मतलब यहाँ equal and resource मतलब input. हमारे पास जो resources जो होंगे वो constant रहेंगे, तो इसलिए इसे iso resource curve कहते हैं. Because each output combination of this curve uses same resources. It is also called as transformation curve as it indicates rate of transformation of one product into another. It is called as transformation because हम एक product को sacrifice करते हैं दूसरे product को produce करने के लिए, इसलिए इसे transformation curve भी कहते हैं. Then there are different types of product-product relationship, or we can say these are enterprise relationship. First is the joint products. These are the product produced through single production process. एक single production process से दो products result होते हैं, तो उसका हम joint products कहते हैं. But as a rule, these are two are combined products. We can say main products and byproducts. These are the joint products. So production of one product, that is जो main product है, without the other, उसका byproduct के बिना possible नहीं है. So main product produce कर रहे हैं तो साथ साथ byproduct भी produce होता ही है. वो without byproduct it is impossible. So level of production of one decides the level of production of other. जितना हम main product का कितना production होता है उसके आधार पे byproduct कितना produce होगा वो depend होता है. Then all farm commodities are mostly joint products. सारे farm commodity, agriculture commodities joint product है. For example, wheat and straw, paddy and straw, groundnut and cotton seed and lean, cattle and manure. So these are the example of joint products. Graphically, we can see that Y1 and Y2, if these are the joint products, then the combination. So if Y1 level of this, if Y1 is the main product and Y2 is the byproduct. So suppose if we take example of wheat and straw. Now suppose this is the initial level of viable. This is the quantity of wheat produced. Then simultaneously with this Y2, this is the quantity of straw produced. Like this, if this quantity increases, the quantity of straw also increases. So the point A, point B, this will show the combination of main product and byproduct, quantity of main product and byproduct produced. So these are the inverted L shape of curves will be C. Next we have the complementary enterprise. Complementarity between two enterprises exists when with change in level of production of one product, the other also changes in same direction. मतलब अगर हमने एक प्रोडक्ट का आउटपुट इंक्रीज किया है तो when resources are held constant, it results in the increase in the other product also. मतलब y1 and y2, y1 हमने इंक्रीज किया तो y2 भी इंक्रीज होगा, तो उसे हम complementary relationship कहते हैं. Now the two enterprises do not compete for the resources, but they contribute to mutual production by providing an element of production required by each other. यहाँ पे ये दो प्रोडक्ट्स compete नहीं करते रिसोर्सेज के लिए, बल्कि वो म्यूचुअल प्रोडक्शन, मतलब एक उसका बाय प्रोडक्ट ऐसा होता है कि जो नेक्स्ट प्रोडक्ट के लिए इनपुट होता है. So likewise they give the beneficial relationship. Now the marginal rate of product substitution is positive, that is greater than 0 in case of complementary enterprise. Example, cereals and pulses, crop and livestock. These are the examples for complementary enterprise. Now complementary relation should be taken advantage. The farmer should take the advantage of this complementary relationship by producing both the products up to point where these products they do not become competitive. So if you see the PPC curve of complementary products, this is the PPC curve. At the point where it is increasing trend, up to this point it is complementary. When it becomes concave, it becomes competitive in nature. Again, it becomes complementary. So this is the within this complementary range, the farmer has to take the advantage. It should not go beyond this. So it should not produce in the competitive range. Next, we have the supplementary enterprise. Supplementary exists between the enterprise when increase or decrease in output of one product does not affect the production level of other products. एक दो products independent है, तो उसे हम supplementary enterprise कहते हैं. They do not compete for resources, but make the use of resources when they are not being utilized by other enterprises. ये दो compete नहीं करते resources के लिए, लेकिन जब एक product resource को utilize नहीं कर रहा है, तो दूसरा product को input utilize करेगा. The marginal rate of substitution is 0 because ये substitution कोई नहीं होता. So, for example, small poultry or dairy, piggery enterprise is supplementary to the farm. Now, all supplementary relationship should be taken advantage by producing both the products up to the point where products become competitive. जब तक ये competitive नहीं होते तब तक उनका advantage लेना चाहिए supplementary enterprise का. Next, we have the competitive enterprise. This relationship exists when increase or decrease in production of one product affecting the production of other product inversely. यहाँ पे inverse relationship होगा. अगर एक प्रोडक्ट का हम प्रोडक्शन इंक्रीज कर रहे हैं तो ऑटोमेटिकली दूसरा प्रोडक्ट का प्रोडक्शन डिक्रीज होगा, तो उसे हम कॉम्पिटिटिव एंटरप्राइज कहते हैं. When the increase in output of one product with the resources held constant result in the decrease of output of other product. Now competitive enterprise compete for the same resources. उनका same resource के लिए वो compete करते हैं. Then two enterprises are competitive in use of given resources if output of one can be increased only through the sacrifice of production of another. Only जब हम दूसरे प्रोडक्ट का sacrifice करें तभी पहले प्रोडक्ट का प्रोडक्शन हम इंक्रीज करते हैं तो हम उन्हें कॉम्पिटिटिव कहते हैं. The marginal rate of product substitution in this case is negative, that is less than 0, and the shape of production possibility curve it will be concave. Next, we have the antagonistic products. Now, two products may be detrimental. Detrimental मतलब harmful to each other because of some similar disease or similar factors. So in such cases they are called as antagonistic product. मतलब एक product दूसरे product के लिए harmful होता है. So this is true only when one product, when this condition is there, only one product should be produced. When this is true, only one product should be produced. For example, aquaculture and paddy cultivation. This is the example for antagonistic product. Then next we have the main concept in product-product relationship is marginal rate of product substitution. The term marginal rate of product substitution has same meaning under product-product relationship as factor-factor relationship. Factor-factor relationship में हमने marginal rate of टेक्निकल सब्स्टिट्यूशन देखा था. सेम कंसेप्ट यहाँ अगर हम प्रोडक्ट प्रोडक्ट रिलेशनशिप में अप्लाई करते हैं तो यहाँ पे वो मार्जिनल रेट ऑफ प्रोडक्ट सब्स्टिट्यूशन होता है. देन मार्जिनल रेट ऑफ प्रोडक्ट सब्स्टिट्यूशन रेफर्स टू एब्सोल्यूट चेंज इन वन प्रोडक्ट एसोसिएटेड विद द चेंज इन वन यूनिट इन कॉम्पिटिटिव प्रोडक्ट. जो अदर प्रोडक्ट का चेंज होता है जिसे हम मार्जिनल रेट ऑफ प्रोडक्ट सब्स्टिट्यूशन कहते हैं. The quantity of one product to be sacrificed so as to gain the another product by one unit is called as marginal rate of product substitution or MRPS. The formula for MRPS is number of units of replaced product divided by number of units of added product. Or we can say that MRPS Y1 for Y2. So in this case it will be delta Y2, that is change in replaced product. Here Y2 is the replaced and Y1 is the added product. So change in Y2 divided by change in Y1. If it is MRPS for Y2 for Y1, Y2 for Y1 मतलब यहाँ Y2 जो होता है वो added होगा और Y1 replaced होगा. So it will be formula will be delta Y1 by delta Y2. So this is important to remember. Based on which factor is coming first, the formula will change. Next, we have three types of substitutions again. First is the constant rate of substitution. For each one unit increase or gain in one product, a constant quantity of another product must be sacrificed or decreased. So this is called the constant rate of substitution. When product substituted constant rate, production possibility curve is linearly and it is negatively sloped. That is, it is linear and it is negatively sloped from left to right. Now, constant rate of substitution occurs when first one of the production function has elasticity greater than 1 and the other has elasticity less than 1. There are two possibilities for having constant rate of substitution. In that first possibility क्या है, अगर एक production function की elasticity greater than 1 है और दूसरे की production elasticity less than 1 है, तो उस केस में constant rate of substitution पाया जाएगा. And if both the production functions have stages of increasing and decreasing returns, जो भी दो हमने प्रोडक्ट्स लिए उसके प्रोडक्शन फंक्शंस के इंक्रीजिंग एंड डिक्रीजिंग रिटर्न्स में है तो उसे उस वक्त कांस्टेंट रेट ऑफ सब्स्टिट्यूशन दिखता है. Then the production possibility curve is linear when the product substitutes at constant rate. We have seen this is the linear curve. Then when two products substitute at constant rate, only one of the two products will be economical to produce depending on the relative price. जब constant rate of substitution में है तो दोनों में से एक ही प्रोडक्ट प्रोड्यूस करना चाहिए जिसका प्राइस हाई हो, जिससे रेवेन्यू ज्यादा मिलेगा वो प्रोडक्ट प्रोड्यूस करना चाहिए. ना स्पेशलाइजेशन इज द जनरल पैटर्न ऑफ प्रोडक्शन. एक ही प्रोडक्ट हम प्रोड्यूस करेंगे तो उसके लिए उसे हम स्पेशलाइजेशन की ओर जाते हैं. So specialization is the general pattern of production under constant rate of product substitution. Next, we have the increasing rate of product substitution. Each unit increase in output of one product is accompanied by larger and larger sacrifice in the level of production of other product. एक प्रोडक्ट का आउटपुट इंक्रीज करने के लिए हम दूसरे प्रोडक्ट का आउटपुट डिक्रीज करते जाते हैं. लार्जर एंड लार्जर हम सेक्रीफाइस करते हैं तो उसे हम इंक्रीजिंग रेट ऑफ प्रोडक्ट सब्स्टिट्यूशन कहते हैं. Increasing rate of product substitution holds true when production of each independent commodity is one of the decreasing resource productivity and non-homogeneity in quality of limited resources. ये कंडीशन कब आती है जब दोनों में दो प्रोडक्ट में से एक प्रोडक्ट में डिक्रीजिंग रिटर्न्स पाया जाता है, तब ये कंडीशन ट्रू होती है. Then production possibility curve is concave in this case, concave to origin when product substitutes at increasing rate. The increasing rate of product substitution, this is commonly found in एग्रीकल्चर एंड इस केस में हमें डाइवर्सिफिकेशन करना चाहिए, मतलब प्रॉफिट्स, वी हैव टू मैक्सिमाइज प्रॉफिट्स बाय प्रोड्यूसिंग बोथ द प्रोडक्ट्स. Next, we have the decreasing rate of product substitution. Each unit increase in output of one product is accompanied with lesser and lesser decrease in the production of another product. एक प्रोडक्ट का आउटपुट इंक्रीज करते हैं बाय सैक्रिफाइसिंग लेस, जो भी सैक्रिफाइस अदर प्रोडक्ट का कर रहे हैं वो धीरे धीरे कम होता जाता है, तो उसे हम डिक्रीजिंग रेट ऑफ प्रोडक्ट सब्स्टिट्यूशन कहते हैं. दिस टाइप ऑफ प्रोडक्शन सब्स्टिट्यूशन होल्ड्स ट्रू अंडर द इंक्रीजिंग रेट. इंक्रीजिंग रेट ऑफ सब्स्टिट्यूशन जो है वो डिक्रीजिंग रिटर्न में पाया जाता है, और जो डिक्रीजिंग रेट ऑफ प्रोडक्ट सब्स्टिट्यूशन है वो इंक्रीजिंग रिटर्न्स में पाया जाता है. The PPC curve, that is production possibility curve, in this case it is convex to origin, when the product substitutes at decreasing rate, and this is not commonly found in agriculture. Only increasing rate of product substitution is found in agriculture. Then if we take the summary of enterprise relationship, when MRPS, that is marginal rate of product substitution, it is positive, the enterprise relationship is said to be complementary. When it is equal to 0, it is supplementary, and when it is less than 0 or negative, it is competitive. So this is the summary of basic enterprise relationship. Next concept we have the ISO revenue line. As the word suggests, ISO matlab equal and revenue matlab the total income. It represents all possible combination of two products which would yield equal, that is same revenue or same income, same level of income. That is the ISO line. As we have seen ISO cost, where cost is same, here revenue generated from the combination of two products will be same. Now characteristics of ISO revenue line. First, it is a straight line because product prices do not change with the quantity sold. जो भी quantity sold है price change नहीं होता, इसकी वजह से वो straight line. As total revenue increases, ISO revenue line moves away from the origin. Since total revenue determines the distance of it from the origin. अगर total revenue increase हो रहा है तो वो origin से farther away move करेगा. अगर total revenue decrease हो रहा है तो वो origin के पास है, यहाँ parallel shift हो जाएगा. लेकिन अगर एक ही प्रोडक्ट का प्राइसेस चेंज हो रहा है तो उस केस में क्या हो जाएगा, द स्लोप ऑफ द आइसो रेवेन्यू कर्व विल चेंज. नाउ सपोज द प्राइस ऑफ y1 हैज इंक्रीज्ड, सो टोटल रेवेन्यू जनरेटेड फ्रॉम y1 इट विल इंक्रीज, सो द आइसो रेवेन्यू लाइन इट विल शिफ्ट आउटवर्ड, एंड इफ प्राइस डिक्रीजेस the ISO revenue line will shift inward. So when price of any one product changes, the slope of ISO revenue line changes, whereas when total revenue itself it increases, there is a parallel shift in ISO revenue line. The slope of the ISO revenue line indicates the ratio of product prices. So as long as product prices remain constant, ISO revenue line showing different total revenues are parallel. But change in either of the price, which will change the slope. The slope of the ISO revenue line, it is given by the price ratio of products. Price ratio of products indicates the slope of ISO revenue line. Next, we'll determine the optimum combination of output produced. So first, we'll by algebraic method, there are 3 steps to calculate the optimum product combination. First step is compute the marginal rate of product substitution. Marginal rate of product substitution, that is MRPS, is equal to number of units replaced divided by number of units added. So MRPS y1 for y2 will be equal to delta y2 divided by delta y1. Second step is work out the price ratio. Now price ratio is equal to price per unit of added products divided by price per unit of replaced product. So in case of if y1 is the replaced product, if we consider y1 is as replaced and y2 is added, so price ratio will be equal to price of y1 divided by price of y2. Now optimum combination is where MRPS is equal to price ratio, that is number of units of replaced product divided by number of units of added products is equal to price per unit of added product divided by price per unit of replaced product. That is nothing but delta y2 divided by delta y1 is equal to price of Y1 divided by price of Y2. So this is the, at this level there is optimum combination of output produced. Now for profit maximization, rational producer should operate in range where two products are competitive, and within the range the choice of product should be depend on the MRS and that MRPS, sorry, marginal rate of product transformation and price ratio. Next we have the by graphical method. We can slope of production possibility curve will indicate marginal rate of product substitution, and slope of ISO revenue line indicates the price ratio of the product. So our optimum combination is MRPS is equal to price ratio. So point at which slope of production possibility curve is equal to slope of ISO revenue curve, it is the optimum combination, and slope is equal when at the point of tangency. The point of optimum combination of product is that where ISO revenue line is tangent to production possibility curve. At this point, the slope of ISO revenue line and slope of production possibility curve will be same. That is MRPS is equal to price ratio. So this is the optimum combination. The point of tangency indicates the optimum combination of two products. So we will see the summary of basic product relationship. We have factor product, factor and product relationship. So in factor product we deal with the resource use efficiency. In factor we deal with the resource combination and resource substitution, and product we deal with the resource allocation among the enterprise. Here enterprise combination, what to produce is decided. Then here under factor and the factor product we have optimization of production is the goal in factor product. In case of factor cost minimization, and in case of product profit optimization. Then question solved as factor product how much to produce, factor what to produce, and product what to produce. In factor sorry, how to produce, product what to produce. Then in factor product we consider only single variable production function. In factor we consider two variable resources or two variable inputs and other inputs are kept constant. In product input is kept constant and the resource is kept constant and output is changed. Factor output is kept constant. In factor product relationship, it guides in determination of optimum input use and optimum output to produce. एक इनपुट एक आउटपुट के बारे में यहाँ बात होती है. फैक्टर में concerned with the least cost combination, and product में determination of optimum combination of products. Then choice indicators, in case of factor and product, price ratio is the choice indicator. In factor product we use substitution ratio, that is MRPS, and we price ratio, this we use as in factor, and in product we use MRPS, marginal rate of product transformation, product substitution, and here marginal rate of technical substitution. For factor product we use the law of diminishing returns. Factor we use principle of factor substitution, and in product we use principle of product substitution and law of equimarginal returns. So mathematically, if we want to represent factor product relationship, we represent it by y is equal to function of x1. X1 here is the variable input, and other are the constant input. In factor we have two variable inputs and other are constant. And in product we explain it as y1, that is one output is the function of other outputs. So this is the summary of basic production relationships. Next we'll see about the returns to scale. By returns to scale, it is mean that behavior of production when all the factors, all the inputs are increased or decreased simultaneously in the same proportion. Return to scale मतलब यहाँ पे जो भी production function है वहाँ पे जो भी inputs utilize है वो simultaneously same proportion में हम increase करते हैं या decrease करते हैं, उसे हम return to scale कहते हैं. The scale relationship refers to simultaneously change in all resources in same proportion. मतलब सारे इनपुट्स हम सेम प्रोपोर्शन में दिए, अगर 4 इनपुट्स है तो 4 के 4 इनपुट्स हम डबल करते हैं या डिक्रीज करते हैं इन सेम प्रोपोर्शन। अगर हम एक रिसोर्स 10 क्विंटल से इंक्रीज कर रहे हैं तो सारे इनपुट्स हम 10 क्विंटल के साथ ही इंक्रीज करेंगे। In other words, return to scale we analyze the effect of doubling, tripling and so on where of inputs. यहाँ पे हम inputs जो है वो double करते हैं, triple करते हैं, and you see its effect on the output. Now, in return to scale, all necessary factors of production are increased or decreased to same extent so that whatever the scale of production, the proportion among the inputs remain the same. When all inputs are increased in unchanged proportion, scale of production is expanded and the effect on output are shown in 3 stages. Now, अगर जो भी हम inputs है वो हम increase कर रहे हैं तो उसके साथ साथ आउटपुट भी इंक्रीज होगा, लेकिन वो 3 स्टेजेस को डिफाइन करेंगे, either increasing return to scale, decreasing return to scale और constant return to scale. Now, increasing return to scale में क्या होगा? When the increase in total output is more than the proportional increase in all inputs. मतलब यहाँ अगर हम inputs को डबल कर रहे हैं तो output is more than double. Now first our suppose we were using x input and our output was y, and now we are increasing 2x. So our output was supposed to be 2y, but it is more than 2y. Then in this case, we say that it is increasing returns to scale. Now return to scale become constant when increase in total product is exact same proportion as increase in output. For example, by using x inputs, we are getting y product. Now if we increase the inputs to by 2x, we are doubling the inputs, then output is also doubled. So this is the constant return to scale. If we are tripling the input, then output also will be tripled. So this is the example for constant returns to scale. In case of decreasing return to scale, the scale diminishes because increase in the output is less than the proportionate increase in the input. Now here if we take the example, first by x inputs we are getting total product of y. Now suppose if we double the input, the production has increased, but the increase is less than the double of output. It was supposed to be 2y, but it is less than the 2y. Then it is said to be decreasing return. मतलब अगर हम inputs 2x से increase कर रहे हैं तो output भी 2y से increase होना चाहिए था, लेकिन वो 2y से कम हुआ है तो उसे हम decreasing return to scale कहते हैं. So graphically we can see, determine the returns to scale. By seeing the isopont map, we can decide whether it is increasing, decreasing or constant return to scale. Now return to scale are more theoretical interest than the actual relevant. ये actual practice में उतना relevant नहीं है जितना कि law of variable proportion है. Law of variable proportion उसका universal application है, and return to scale it is the theoretical, more theoretical concept. Return to scale can be also explained by using the knowledge of scale line and isopont map. Isopont map के द्वारा हम return to scale को explain कर सकते हैं. Now, in case of constant return to scale, the distance between the successive isoponts is constant. अगर हम isopont map ले, अगर उसमें successive isopont में जो distance है वो equal है तो उस case में हम constant return to scale कहते हैं. You can see here. Now the distance between the two isoponts or successive isoponts is constant. Now suppose first this is the initial input level. Now input level has doubled, 2k and 2l. So output has also doubled, that is 2x. Likewise, when it is triple, input is 3x. So likewise, we have seen this is the constant return to scale. Next we have the, if distance goes on widening, that is the distance between the successive isoponts goes on increasing, then that is decreasing returns to scale. अगर distance increase होता जा रहा है तो it is decreasing return to scale. यहाँ पे inverse relationship है. अगर distance इंक्रीज हो रहा है तो इट इज डिक्रीजिंग रिटर्न टू स्केल. यू कैन सी हियर द इनपुट इज डबल्ड. Input is double here because of doubling the input the output which has produced. It was supposed to be 2x, but it is less than 2x. So it is decreasing return to scale, and the distance between the successive isopods it is increasing. So this is decreasing return to scale. Now if the distance between the successive isopods becomes smaller and smaller as we move away from the origin, then this is said to be increasing return to scale. So this is the case of increasing return to scale. So you can see here the distance between the successive isopod is decreasing. And now if you see here, if we double the inputs, that is 2k and 2l, the output is the output which is produced, it is more than the 2x. First it was supposed to be at this level, but it is at more than 2x. So this is increasing returns to scale. The return to scale is also can be measured by using Cobb-Douglas production function. जो भी हम प्रोडक्शन प्रोसेस है, अगर हम उसे Cobb-Douglas production function में फिट करते हैं, then by adding the exponent in the production function or the production elasticities, then we get the return to scale. Now for example, suppose our Cobb-Douglas function is y is equal to a into x1 raised to b1 into x2 raised to b2, x3 raised to b3, and so on up to xn raised to bn, where y is the total output, x1, x2, x3, xn are the variable inputs, and b1, b2, b3, bn, this is the elasticity coefficient. Then return to scale from this production function is given by summation of individual elasticities of coefficient. मतलब जो भी यहाँ elasticity coefficient है b1, b2, b3, इसका हमने summation लिया तो हमें return to scale मिलेगा. The return to scale is equal to summation of bi. Bi it ranges from 1 to n. Now suppose if this summation is greater than 1, the value of this summation, if it is greater than 1, it is increasing return to scale. If it is less than 1, it is decreasing return to scale, and if it is equal to 1, then it is constant return to scale. So based on Cobb-Douglas production function also we can determine return to scale.